worksheet number 6 for Academic Decathlon 2025. And we are warming up with simplifying. So orders of operations again we have. And simplifying, we need to remember, so these are absolute value bars. We have to simplify inside the absolute value before we take it. It is a form of grouping symbol, so I would do it before exponents. In this case, either one's fine, but absolute value of 20 is 20, so you have 5 cubed minus 6. Now it's times 20, because that operation in between here is multiplication, but we have to do the absolute value. 5 cubed, I think it's like 125, minus 6, 120, and that gives you 5. I'm pretty sure 5 cubed. 5 cubed, 125, yeah. Good, that's a nice little warm-up. Simplify, so this is a binomial square. Whenever we have a plus b quantity squared, it's going to create a squared plus 2ab plus b squared. So whatever a is, you're going to square it. Then you're going to do a times b and double it. So this value times this value and double it, and then you'll square your b value. So it's x squared, and then multiply these two together. X times 4 is 4x, and double it is 8x, and then square your b term, which is 16. Now we're going to distribute this, which is negative 3x plus 21. We'll combine like terms, which are going to be 8x and negative 3x, which gives us 5x. We have constants that we can combine also, which is 37. And those cannot be simplified any further. Okay, now we have absolute values. We've got operations inside here, so it's 0.05 times the absolute value of negative 7 plus 9, all over 19 minus 2 to the third, 19 minus 2 to the third. So we'll simplify this, and that's 0.05 negative 7 plus 9. That's times the absolute value of 2. 19 minus, we can do this denominator. So this is very important to see that this is the opposite of 2 to the third. No parentheses there. Yeah. No parentheses there. So we do not include the negative. It's the opposite of 2 to the third, which is negative 8. Now, we have to be careful of that and make sure that we simplify that properly. And then we have 0.05 times the absolute value of 2 is 2. And 19 minus 8 is going to give us 11. And then 0.5 times 2 is 0.1 over 11, which is 1 over 110. Yeah, so I think we can leave it as a fraction. Oh, I didn't do it that big. And I moved the decimal point, So I like 1 over 110 is pretty good. All right, simplify the expression. So we're going to square this. This is the opposite of r squared s squared. We can distribute exponents into parentheses. Plus 2rs minus 3r. And let's take this. Instead of doing, okay, we'll keep the parentheses. Instead of doing division, let's do multiplication, taking the reciprocal. So that is, we'll distribute the 2 in there. You have to distribute it in. So negative 2r squared s squared plus 4rs minus 6r all over r. And now this r, it needs to be done under each of them. So when you cancel it, you just don't cancel one of them. You have to cancel in each of them. because technically this is distribution. It's negative 2r squared s squared over r plus 4rs over r minus 6r over r. These are the same statements, and that will give you negative 2r s squared plus 4s minus 6 is going to be your answer. All right, now let's use that in solving equations. So this is a tricky one because you have to distribute the negative. So that's 2r minus 3r minus 5 equals 11r. We'll distribute this 2 in there, plus 2r minus 12. Let's simplify the side first before we start moving variables. Simplify the sides. And now always move your variables first. My advice to you is to move the variables first. And then we're going to add 12. And that gives us 7 equals 14r. Divide by 14. And 1/2 equals r. And you could always check. And that 1/2 is 1. 1/2 is 3/2, which would give you 3/2. 1 minus, no, that would be, yeah, 7. 7/2. 7.5. 8, so what, negative 6.5? Well, we'll check on another day. We can again put that 6 under both of the terms. We can we can separate it and write it like that. That'll give you x over 60 because we move the decimal point, and this is 1/3 equals, this is going to give you 3 over 2x plus 18x. I guess we could have combined those. We could have added those first. It's kind of bad. So that's technically equal to 36 over 2, so 39 over 2x. Let's minus 1 over 60x minus 1 over 60x. Let's get a common denominator. Hiya. That's 30. That's a huge number. All right, let's see what I did. Did I do this okay? That's okay. That's okay. I probably should have added those together first. But that's okay. 3 over 2. That's definitely 18x. That is 36. 8, 9, 16, 36 over 2 plus 3 is 39. Yeah, that's correct. Okay, you get 1/3 equals, and that's equivalent to times 30. So that's 0, that's 7, that's 1, 1070? 1070 over 60 x. Let's just do that math real quick. 39 times 30. 39 times 30. 1170. Oh, we're minusing also. Hello. 1170 gives us 1169. 60 over 1169. Okay. That cancels. That's 20. 20 over 1169 equals x. Really? I mean, what are we doing here with that answer? What is this? This is number 2. Number 2. Yeah, Mr. Mac made some major mistakes. Okay. Let's see what we did wrong. We did some major stuff wrong. So Let's re-look at it. That's okay, that's correct. Or maybe the starting problem. Maybe I didn't copy the starting problem correctly. Let's look at the starting. Because clearly, math contest, content. What's that, worksheet 5, 6? We're on worksheet 6. Five. No, that's correct. That's what I have. Okay. 2 6 equals 1/3. I mean, the only weird thing is I could have added that as 6 1/2, which is 13 halves, right? 13 halves times 3x doesn't change it. That's 39 over 2. Yeah, that's okay. 39 over 2. And I mean, could I multiply both sides by okay, I could do this. So let's do this. Let's go backwards a little bit. No, let's do this. Let's go here. What's this? Let's take this. Let's copy it. I think that, oh no, not cut, paste. Let's go to a new page and paste. And instead of having, let's do this. Let's make this 39 over 2x, which is what we said, right? 30. Whatever happened though. Yeah, that's come on. Sorry about this. Yeah, 39.2, and then let's do this. So 39.2, that's that simplified, and we have 0.1x plus 2 over 6. Let's multiply both sides by 6. That's kind of fun. Okay, so 6 cancels, that's 3. So these cancel. You're left with 0.1x plus 2 equals, and now that's 27. That's 117x. Is that correct? Yeah, I think my answer's right. That's 27. That's 9, 10, 11. Yes. And now we're going to minus 0.1x minus 0.1x, which is 2 equals 116.9x. Divide by 116.9. Yeah. 116.9. There's no, what? Yeah. They messed up. They messed up again. I don't know what, they keep making so many mistakes. So, that's 20 over 1169 equals x. I think that's what I had initially. 20 over 1169. Yeah, I'm right. They're wrong again. Come on, academic decathlon. Making me waste all this time. All right, let's distribute. And distributing gives us 2y. Distributing gives us negative 0.9 over 3 is less than or equal to 5y plus 1.7. Let's move it. That's 9 over 30. Negative 9 over 30. That's not a 6. That's a 0. 5y plus 1.7, 2y, if we divide it by 3, is 3/10. Okay, or 3/10. Let's make that just 3/10. 0.3 is less than or equal to 5y plus 1.7. Move the variable again. 2y. Negative 0.3 is less than or equal to 3y plus 1.7. Let's now move, and that's negative 2 is less than or equal to 3y divided by 3 divided by 3. Negative 2/3 is less than or equal to y. Just say that we have to graph it too? Nope, just solve. All right, here's that technique. We're going to multiply by -6 first. Now, since we're multiplying both sides by a negative, we have to flip the inequality. That's negative 16t minus 8 is now less than negative 6 times 8 is 48, and negative 7 times 6 is positive 42. Let t, negative 48t, let's move the 48t over, and we'll move the 8 the other way just for fun. That gives us not 30, 20, no, 32, 32. 32t, yes, is less than 50. Divide by 32, divide by 32. T is less than 25 sixteenths. Yeah. What gets rid of a square is a square root. Whenever we take the square root of a variable being squared, we have to introduce plus minus. So x equals plus or minus 7. And we put it in a solution set like that. We're going to divide by 2 first. We get x squared is less than or equal to 36. Now we're going to take the square, square root. That's an interesting one. I don't think I've ever, is less than or equal to plus 36. And I would say that it's going to be x squared is greater than or equal to minus 36. The square root, sorry. The square root. That's when I think that that'll be interesting. We're going to have to think about this answer. X is less than or equal to 6, and x is greater than or equal to -6. Those are my solutions. So it is, and it's less than, so that's going to be an and statement. So I think our solutions are between -6 and 6. Closed circles. Looks like that. So you would write -6 is less than or equal to x, which is less than or equal to 6. Let's take 7 is not going to be, right? 7, anything outside of 7, 7 is going to give us a number that's much bigger than 72. Let's think of 0. 0 is less than. Let's think of -6 is going to give us equal to it. And then if we go outside that, yeah, wow, that's kind of cool. So that negative stays outside there, that radical, but we have the negative and positive of that, much like when we do absolute values and compound inequalities. Let's simplify. So you cannot distribute the 2. You're going to have to do this exponent first. So that is 2 times x squared. Multiply these 2 and double it, and then square minus 5 is equal to 123. We don't have to distribute. Let's add the 5. That's Chewbacca in there. That's how a high school student would do this problem. Instead of creating more work, equals 128 divided by 2, x squared plus 6x plus 9 is equal to 64. Okay, well, we should have done that. So this is a binomial square. We'll actually turn it back into this, and then we will take the square root of both sides. We'll take the square root, and we have to do plus or minus. So we get x plus 3 equals plus or minus 8. We'll subtract the 3, and we get x equals negative 3 plus or minus 8. So negative 3 plus 8, or negative 3 minus 8. That's 5. That's negative 11. So negative 11 or 5. Those are my solutions. And you can look for extraneous, just making sure. Yeah, it's fine, because we're going to put in our negative number, we'll square it, and that'll work out just fine. Absolute value, hey, we know that nothing is going to come out of here. Even doesn't matter what number, it's always going to be positive coming out after we plug in this value. Even if it's negative, it's going to come out positive. So it's never going to equal that, so that is no solution. It's good to see absolute values. Let's isolate the absolute value first. So before we make any determination, 1/2 y is greater than 16. Let's divide by 8. The absolute value of 1/2 y is greater than 2. Now we write two statements, and this is an or statement because it's greater than, than 2, or 1/2 y is less than negative 2. So not only do we take the positive and negative direction, this distance, but we also have to flip the inequality sign. So we'll multiply by 2. We get y is greater than 4, or multiply by 2, y is less than negative 4. So on a number line, that looks like negative 4, open circle going to the left, 4, open circle going to the right, or you could have this. You can have y is greater than 4. Probably do the negative. Let's do the negative side first. Less than negative 4, or y is greater than 4. That's our solution set. Again, we're going to isolate first. 3 times the absolute value. You cannot distribute into absolute value, into absolute values. You need to remember that. That is a common mistake. Divide by 3. Absolute value of negative 5 equals 7. We write 2. This distance needs to be 7. Well, what is 7 away from? 7 away from 0 is positive 7, and 7 away from 0 is negative 7. So x equals 12 plus 5 plus 5, x equals negative 2. So my solution set is going to be negative 2, 12. Those are my two solutions. System, solve the system. We're going to use substitution, and we use substitution because it's isolated. So we're going to plug it into this equation. We're going to rewrite it. 3, instead of writing y, we write 2x plus 7 equals 15x minus 6. And the reason we do that is we have two variables in both of these equations. Using the substitution method, we now only have 1. So that's 6x plus 21 equals 15x minus 6. We'll move the variable. We'll move the constant to the other side. 27 equals 9. 9x divided by 9. 3 equals x. And then we go back and we plug in the other. So we have y equals 2x plus 7. And then we plug in 3 for x to get my other. That's 6 plus 7. Y equals 12. So these are coordinates. So you can write it with parentheses, different from solution sets. Parentheses are show that it's a coordinate xy, so it has a position. Yeah, we can solve and substitute. So I mean, I guess I'm going to add 27 and get negative 5x plus 27 equals y. And I'm going to substitute it into this equation. So 2 times negative 5x plus 27 equals, and we'll do that out. That's going to be x squared, multiply the 2 and double, negative 6x plus 9. That's going to be negative 10x plus 54 equals x squared minus 6x plus 9. Let's move and set it equal to 0. So move everything to one side. 0 equals x squared plus 4x minus, what's that, 45? Now we want factors of 45 when subtracted equal 4. That's 5 and 9. So this is going to become x, x plus 9, x minus 5. Oh, that's a horrible 5. And we're going to use the 0 property. And what value would make this 0? No, negative 9. What value would make this 0? 5. And those are my two solutions. Sorry, those are my two x values. At least I use solution set. Those are my x values. This is a system. So now we go back to this equation, and we're going to find both of them. So negative 5 when x is negative 9 gives me 45 plus 27, which is 72. So 1 point is going to be negative 9, 72. And the other solution is when negative 5 times 5 plus 27, which is negative 25 plus 27 is 2. So my other coordinate is going to be 5, 2. Those are my two solutions to the system. And that makes sense because this is going to be parabola, this is going to be linear, so we're going to have something that's going to look like this. So we'll have two solutions. Oh, this is good. So we know this is going to look like a V, absolute values. This is going to be a linear, no, excuse me, it's going to look, sorry. That's equals Y, so it looks like this, and it's going to look like that. Oh, nope, that's not true. This is a negative coefficient, so that's going to be upside down. So it's still going to look like that. So we may have only one solution. So we'll plug in y equals 9 into the other equation. So we get 9 equals negative 3 times the quantity, or times the absolute value. Let's divide by negative 3. And we get 3 equals the absolute value of x. And we get negative 3 and positive 3 for my x values. And let's plug it in. Plug it in, you're going to get one value. Yeah, you're going to get 1 point. So your point is, your point, if you plug in negative 3, you get negative 9. And you plug in 3, you get negative 9. That's 2 points. So let's look and see what that looks like on Desmos, shall we? Let's see what that looks like on Desmos. That's not SeatGeek. Desmos. So we'll say, what's our equation? Y equals negative 3 times the absolute value of x. And then, oh, y, hello. Yeah, right. And then y equals negative 9. Negative 9. Yeah, sorry. So I made a mistake. It's not that. It was y. It's going to cross the y-axis at negative 9. So it was 2. And it makes sense because we got 2 solutions. Good. That's a good one. 13, 14. Same thing. Let's plug it in. We get y minus 7 equals 1/2 times the absolute value of negative 11 minus 3. So y minus 7 equals 1/2. That's negative 14. Y minus 7 equals 1/2 times 14. Y minus 7 equals 7. Add 7, add 7. Y equals 14, Mr. Mac. 14. And you have x equals negative 11, so your solution is negative 11, 14. 14. You only have one x value. So that's a weird, right? So, yeah, this is the one. Yes, sorry. This is the one where it goes like this, because this is a vertical line. All right. Let's see. Oh, isn't that interesting? They don't want, oh no, that's okay. We got that. Let's see this. Yeah, so they do give the coordinates. This is good. Okay, awesome. Outside of that one problem that they got wrong, which was not that one. They got this one. This one's wrong. That's wrong. That is wrong. Yeah. Yeah, no way. It's just produces such a big number. They made a mistake. All good. All right, enjoy.